Hey guys, in this lesson we're going to be talking about factoring trinomials squared. So the title of today's notes is right there. It is factoring trinomials squared. Another way of saying that is factoring quadratic expressions. So trinomials squared and quadratic equations are basically, you guys have expressions with three terms, right? Trinomial. And the highest power of that trinomial is squared, which means it's to the power of 2. So it's factoring trinomials squared for today. So definition. Let's start with what is a trinomial squared? A trinomial squared is a polynomial. Remember, polynomial means many terms, so more than three terms typically. With in this case, the trinomial would be three terms, and the highest power of the trinomial is a power of 2. So you've already seen this before in the past, and I'll show you what we're doing in a minute because you've already done it, but we're doing it backwards. Because remember, we're talking about factoring. Factoring is undoing the multiplication of something. For example, in this class, you've already seen, let's say you guys have x plus 2 multiplied by, I don't know, let's say x plus 1. Or let's put a 2 in there. So let's say we have x plus 2 multiplied by 2x plus 1. And you want to multiply that out. You've already learned in this class that if you want to multiply that out, you would do a box, right? You would put the two terms on one side, so x plus 2 on one side, and then you put the other two terms on the other side. So in this case, 2x plus 1 on the other side. And then you got to figure out, okay, what do I need to put on the inside? So you multiply it out. This will be 2x squared. This will be 4x. This would give you an x, and this would give you a 2 when you multiply it out. You add the peanut, right? So this is all review. You add the peanut, which in this case will be the diagonal, and the final product of these two binomials multiplied together is 2x squared, right? So we write the first term, and then we write the middle term, which is positive 5x. And then the final term is 2, which means it's positive 2. So this is the final answer when you multiply those two things together. So we've already done that in this class, right? So you multiply this times that, and you get the answer as that. This time we are factoring, which means that we're actually going to be going the other way around. We're going to be starting with this guy right here, and we're going to try to figure out, okay, what do I do to get this and break it apart into its original form? Meaning like what times what gave me that? How can I break that up? So that is what we're going to be talking about today. So for factoring trinomials squared, which is right here, trinomials squared are also referred to as quadratics because they form a square. As you guys saw, what did you draw, right? When you created this, you drew a box, meaning like a square. So that's why they're called quadratics for the most part. When you factor a quadratic expression, you get the product of two binomials, which we just saw. So this is a standard form for a quadratic expression. The quadratic expression in standard form is the following. So it is the function in terms of x is equal to ax squared plus bx plus c. So remember that equation because you're going to be using it basically for the next month or so, for quite a while in this class because we're going to be talking about quadratics basically for most of the month in this class. So just FYI. So if you notice, the coefficients means that the terms in the front, right? So we have three coefficients. We have the coefficient of a, which is in front of the x squared. We have the coefficient of b, which is in front of the x. And we have the coefficient of c, which does not have a variable at all. So make sure you pay attention to these coefficients because you're going to need to know them to be able to apply these concepts for factoring and other concepts we're going to be looking in this class. So you need to know what a, b, and c is. For example, before we move on, it's really important for you to know that. So let's say we have, let me change the color on this because it's kind of too dim. Let's say we have negative 2x plus 6x squared plus 6. And if I were to ask you what is a, b, and c, you should know that a is the number in front of the a squared. So in this case, a is equal to the 6. B is equal to the number in front of the x. So in this case, b is equal to the negative 2. And then finally, c is the number that doesn't have a variable. So in this case, c is going to be equal to 6. Be careful because in this case, I give you the terms unorganized. You need to put them in standard form, right, for you to be able to identify a, b, and c. So if you need to move stuff around to be able to put it in standard form, you should do that. So I'll do one little quick last example, and then we'll move on into other things. So let's say we have negative 8 plus 6x minus 2x squared. If I were to ask you what is a, b, and c in that, you should know that a is the number in front of the x squared, so a is equal to the negative 2. B is in front of the x, so in this case, sorry, b is in front of the x, so in this case, b is equal to 6. And then finally, c is the number without the variable, which is negative 8. So I would write c equals negative 8. Let me erase that. So there you go. You're going to need to know what A, B, and C is. You're going to need to know how to identify them clearly. Don't forget the signs. Remember, I put negative 2 and I put negative 8 and all that in here because the signs do matter. So don't forget the signs when you're doing these problems because they will mess you up. Okay? So what do you need to know to be able to factor quadratic expressions? So these are the following steps. I'm going to talk about them. If you want to go ahead and pause the video and write these down, you should. I recommend you doing that while you're taking your notes. But these are basically essentially the steps. So the first thing you need to do is step 1, identify the coefficients A, B, and C, which we just talked about. So figure out what's A, what's B, what is C. Step 2, you're going to draw a large X, so a big X. Step 3, you're going to multiply the A and the C together with each other and put it on top. Make sure you watch your signs. That's what I was saying. Be careful with your signs. Don't forget them. Step 4, you're going to place B on the bottom. So whatever number you guys got for B, you're going to place that on the bottom of the X. Step 5, this is the part that's going to be the most difficult step. And the reason why it's difficult for some people is because you need to know your multiplication tables. If you don't know your multiplication tables very well, then it's going to be very hard for you to do these problems, meaning that you probably will need a multiplication chart to help you. So if you need a multiplication chart when you're doing this, no big deal, use it. But just letting you know that you will need to know your multiplication tables very well to be able to find the correct combinations. So step 5 says, find the combination of numbers that multiplies to the number on the top, but adds to the number on the bottom. So find the combination of numbers that multiplies to the number on the top, but adds to the number on the bottom. Step 6, so that's a hard one. Step 6, you would write your answer as a product of two binomials starting with AX. And then step 7, it would be divide the coefficients of each part by the GCF. If there is a common factor, you would divide each part of it by a common factor. And then finally, verify your results to make sure that it matches the original problem. So in all of these problems, this is an assumption that I forgot to write down in these steps. So I'm going to go ahead and write this here and underline it because it's very important. So make sure that your trinomial is factored out. And by that I mean from common factors. So if there is a greatest common factor that there is in all three, make sure you take out the greatest common factor first before you even start the problem. I didn't write that, but it's kind of important because sometimes that will get you the wrong answer in the end, and it'll make step 8 not work. And you'll be like, why? How come it doesn't multiply to the original expression? And the answer to that will be that you don't have, you didn't start with the trinomial already factored out, meaning that you could have taken out the GCF and you didn't. So I'll show you an example of that. But for right now, let's go through the steps. Okay, so forget about what I just said. Just clear your mind for a minute. So we have this problem, right? And it says we want to factor out the expression 2x squared plus 7x plus 3. So at the end of this problem, I need to get something multiplied by something else that will give me that original problem. So first, let's start with what is A, B, and C. So this is already organized for us. As you can see, in this case, A is equal to the number 2. B, in this case, is equal to positive 7. And then C is equal to the positive 3. So everything's already ready to go for us. All we have to do is do the following steps to be able to figure out what are the factors that I need. So the next step says, okay, we need to draw a big X. So I'm going to put a big X, nice and big. on top of the x, I need to multiply a multiplied by c. So here is going to be the a, whatever that number is, multiplied by the number c, whatever that number is. Every single time, same thing. On the bottom, I'm going to leave the number b by itself. Okay, so now, as you can see, a multiplied by c in this example, 2 times 3 would give me 6. And then 7 is b, so I'm going to leave the 7 on the bottom. So now this is the hard part, which is step 5. So we need to figure out what is the combination that multiplies to the number on top, but adds to the number on the bottom. Meaning what combination of two numbers multiply to the number on the top, but adds to the number on the bottom. Some of you guys already figured that out. The combination of that would be the numbers 6 times 1. Why? Because 6 times 1 would give me the product of 6, but 6 plus 1 would add up to 7. So like I said, this is the hard part. You're going to need to figure out your multiplication tables very well, because you're going to need to figure out the combination of numbers that work out for both of these. So once you have that, step 6 says, okay, so now that I have this was the hard part. I'm going to go ahead and rewrite the two binomials as ax, meaning that the first number, which was 2, right? I'm going to go ahead and put the 2 in there, and then the x. And then I'm going to do that for the other side as well. The 2, and then the x. And now the numbers that I just got from my big X is positive 6 and positive 1. So I'm going to fill in the blanks here with a positive 6 and a positive 1. Now, I would say you're done, but you're not. So the last thing you need to do is figure out, divide the coefficients of each part by the GCF, meaning that any factor that goes into both of those numbers, you're going to need to divide them on both sides. As you can see on the right side, nothing goes into 2 and 1 besides 1, so I'm going to go ahead and skip that. But on the left side, what can you divide by 6 and 2? The answer to that would be 2. So when I divide this side by 2 and this side by 2, this cancels out, so I'm going to be left with just x, and then this turns into a 3. So my final answer would be x plus 3 multiplied by 2x plus 1. So that would be the final answer. Again, don't trust me. Don't trust yourself either. When you guys want to check your answer, just really quick, check it. I mean, you got the answer already. It doesn't hurt to just check it with the box real quick to make sure you're doing it right, just in case, So if I want to check it to make sure that I did it correctly, this is an extra step. This is just to check. You would be done right here, but just for the heck of it, let's figure out if we actually did it right. So x plus 3 multiplied by 2x plus 1. So that gives you 2x squared. That gives you 6x. And then this gives you x. And then finally, this gives you 3. So when I combine like terms, this should give me 2x squared plus 7x plus 3. So 2x squared plus 7x plus 3. And looky, this is actually the original problem that we had in the beginning. So we did it correct. So follow the steps. Once you get to the end, if you did it perfectly correct, great. But for the first couple of problems, especially when you're doing it for the first time, you want to check your answer by multiplying it with the box. So this will be your final answer, the completed and simplified factored form. Okay, that was a lot of information. So we'll do a couple more examples. Hopefully it's not too bad. And then I'll give you guys a couple of additional examples too for you to try yourself. So example number 2, factor the following expression. So we have these 3 terms. Again, it's already organized for us. This is the number in front of the x squared is a, so I'm going to say a is equal to 3. The number in front of the x is equal to b, which in this case is equal to negative 7. The number that doesn't have a variable is c, so in this case c is equal to positive 2. Now I have to go ahead and follow the rest of the steps. So I want to factor this. I'm going to make a big X. I'm going to multiply a times c and put it on top. That would be 3 times 2, which would be 6. I'm going to put 6 on top. So that would be a multiplied by c. And then on the bottom, I'm going to put b. So I'm going to leave that as negative 7. And then that was b. So now, again, like I said, same exact deal. We have to figure out the combination of numbers that multiply to the number on top, but add to the number on the bottom. So you want to figure out that combination that multiplies to the top number but adds to the bottom number. So think long and hard about this. What two numbers multiply to get 6 but add to get -7? I'll give you guys a minute to think about it. If you guys said -6 and -1, you are correct. So if you multiply the -6 times the -1, that will give you the product of a +6. And if you add these two together, -6 minus 1 would give you -7. So now that you have that, again, this was the hard part. So if you know your multiplication tables, you'll be fine. Now we're going to be writing down the products as 3x, because remember, don't forget the a. There's an a in front. So 3x plus blank, and then 3x plus blank. In this case, the blanks that I'm going to put in here are going to be the -6 and the -1. So I'm going to put -6 here and -1 here. And then I got to stop and think, okay, is there anything that I can divide both of these numbers by, or any of these numbers by? For the first two, the answer is yes. As you can see, these two I can divide both by 3. So I'm going to go ahead and divide them by 3 on this side. On the right side, I cannot divide this by anything except for the number 1, so I'm going to leave it alone. So my final answer is that the binomial, once you factor this out, is equal to x minus 2 multiplied by 3x minus 1. And this will be your final answer. Okay, like I said, if you want to check your work, it's not that hard to check your work. All you got to do is multiply this out, see if it gives you the original problem. So if I multiply this out, x minus 2, 3x minus 1, this will give me 3x squared, this will give me -6z, this will give me -x, and this will give me +2. Combine like terms, meaning add the diagonals, so we get 3x squared minus 7x plus 2. Bingo, that's the original problem, so we did it correct. Okay, so for the first couple of times, check your work. Once you get the hang of it and you know that you're doing it right, then you can skip this step altogether since you know that you're pretty much good to go. I'll do another example with you guys, and then I'll give you guys 3 more examples to try yourself. That way you can check your answers. So, okay, example 3. So factor the following expression. So we have 8x plus 3x squared plus 4. So first thing you need to do is identify a, b, and c. Now this time, be careful. They do not make it easy for you because it is out of order. So as you can see, a is the number in front of the a squared. So the x squared, excuse me. So a is equal to +3 this time. So be careful. B is the number in front of the x, which in this case, b is equal to +8. So I'm going to go ahead and write b equals 8. And then finally, c. C is the number that doesn't have a variable at all. So I'm going to call c the number 4. And they're all positive, so I'm just going to write them all as positive. Okay. Next thing we need to do is make a big X. So somewhere on the side of your paper, make a big X. You're going to multiply a times c, and then put it on top, and then b, we're going to put it on the bottom. So a times c, that'll be 4 times 3, which is 12. B, we're going to put it on the bottom, which is the number 8. Okay. So now this is the part that you have to think really hard about. Some of them will be easier than others. It's kind of like a riddle. What are the two numbers that multiply to the top number, and what are the two numbers that add to the bottom number? So they have to work for both of them. It can't just work for one. It has to work for both. So as you can see, 4 times 3 would give you 12, but 4 plus 3 would not be 8. It would be 7, so that would not work. So the actual combination that this would be, it's actually 6 times 2. 6 times 2 would multiply to 12, but add to the number 8. So then this is the correct combination that you need to have. Once you have the correct combination, the rest is the same. So I'm going to go ahead and write the two factors as 8x and 8x. Don't forget the a, which is in front of the... Oh, no! I fell for it. See? This is exactly why I'm doing this. Why is that a problem? Because it is actually not a. Or a is not the number 8, I should say. So a is actually the number 3, which is actually this one right here. 3x squared, right? So when I write the products, I need to make sure to include ax, which in this case happens to be 3. So I need to say 3x on this side and 3x on this side. Now I need to incorporate the answers to the riddle that I just found. So what the two numbers were +6 and +2. and then figure out if there's any of these two that I can factor out. If there is, then go for it. If there isn't, then don't do it and you're done. So as you can see, this can be divided by 3 on both sides, and this cannot go into, nothing can go into both of these except for the number 1, so I'm just going to leave it alone. So when I do that, my final answer will be x plus 2 multiplied by 3x plus 2. And this will be my final answer. Again, you don't have to check every single time, but for your first, I'm going to go ahead and say your first like 4 or 5 problems, go ahead and check it. Just to make sure you're doing it correctly. So if I multiply this out, I should get the original problem. And as you can see, when I write my factors, x and 2, and then 3x, and then 2, it should multiply out to 3x squared, 6x, 2x, 4, which means that when I combine like terms, I should get the original problem when I add the peanut. So 3x squared plus 8x plus 4. Which if you notice is the exact same thing as the original problem. It just looks a little bit out of order, but 3x squared is right there, 8x is right there, and then 4 is right there, all positive. So there you go, you did it right. So those are all the examples that I have for you guys. If you want some really quick practice right now, you can go ahead and try this example. So I'm not going to go over this example with you guys because I don't want to make this video longer than it has to be. But try to factor out the expression 4x squared minus 2x plus 7x. See if you can get the answer to that. Also, the other example that I have for you is 15x squared plus 19x plus 6. Try to see if you can factor that out. So once you have that, if you want to go ahead and pause the video, try these out, and then I'm going to do them really, really quick. This time I'm going to go fast. Okay, so I'm assuming you already tried these problems. So let's go ahead and go over them really, really quick. So this is the same thing as if saying 4x squared plus 7x minus 2. So I'm going to go ahead and do the x. I'm going to multiply a multiplied by c, which is going to give me a negative 8 on top. I'm going to put 7 on the bottom. I need 2 numbers and multiply to the top number, but add to the bottom number. So what 2 numbers would that be? So 8 times negative 1 would give you negative 8, but 8 minus 1 would add to 7. So those are the 2 combinations that I have. Now I'm going to skip to my factors. So this is 4x and 4x. So I'm going to write 4x plus 8 on one side, and I'm going to write 4x minus 1 on the other side. Then the last thing I need to do is figure out if I can divide any of these by the same term. In this case, I can. I can divide both of these by 4. So my final answer is x plus 2 multiplied by 4x minus 1. Boom. So if you guys got this answer, congratulations, you got it right. I'm going to do the last one in case you did it as well. I had another one, but I'm not even going to go through it. You can do it on the handout. So let's say you wanted to figure this out right here. Now this one right here is very important. I started drawing the x, but then, oh my God, something very important occurred to me. I cannot do this yet. Why can't I do this yet? Because I haven't taken out the greatest common factor from these numbers first. The numbers are really, really big, first of all, right? Actually, no, just kidding. Time out. It's doable. I was thinking that you can actually take some number out of all these, but I don't think you can. So I think you're good to go. So let's do it. So 15 multiplied by 6, that's 90. And then 19 goes on the bottom. Now you want 2 numbers to multiply to the top but add to the bottom. Oh, that's easy. 10 times 9. So 10 times 9 is 90, but 10 plus 9 is 19, so that actually works out. It's easier than I thought. Now we write down the first 2 terms, 15x, and then we got to figure out what goes in these blanks. So in this case, I have plus 10, and here I have plus 9. So once you have these two, figure out if there's anything that you can divide both by. In this case, I can divide these two by 5. And in this case, I can divide these two by 3. So then try to see if you get the exact answer. So when I divide these two by 5, I get as my final answer as 3x plus 2. And when I divide these two by 3, I get 5x plus 3. If you multiply this out, you should get the original problem, which is this right here. Okay. If you want an additional example, you can do this one. I am too lazy. I think you guys have plenty of examples by now. So go ahead and do the handout, the corresponding assignments. And I hope you guys understood this lesson. If there's any questions, let me know. See you on the next one.